So today we're doing implicit differentiation again. It's going to be, if you look at that, you have a y and an x. So we have both of them that we're dealing with. We're going to take the derivative with respect to dx. So it's going to be, we were looking for something that says dy dx. Now, why are we doing the derivative? Well, the directions that we're asking here, it says find the equation of a tangent line to follow the curve of the indicated point. The main thing you need to remember is that it's talking about a tangent line. And so the tangent line is found using the derivative on there. And so we know that any curve, and in this case, the curve that's given to us is this equation here. And so any curve has a tangent line. The tangent line is the derivative. But there's more information. We want a line there. So we know that the form is going to be y is equal to mx plus b. And so in order, the tangent line is going to have the same slope on any of the curves on there. So if I looked at any curve, that's not what this is on there. But if I would look at it, the tangent line is, we want the slope of that, and then we need the y-intercept. So from the slope, we use our derivative, and then we have to find our y-intercept because we already know a point. So for any equation of any line, we need a slope and we need a y-intercept. So we need a point and a slope, and then we could find the equation of any line. Okay, so here's the equation that we have on there. It is, if you look at it, you could do the difference quotient, I'm sorry, not the difference quotient, the quotient rule on there, because it is a fraction and we do have a denominator. But what we're going to do instead is we're going to work it out where I'm going to multiply this side by y plus a. So we're going to get y times y. So we're going to get y and y plus a and equals 2x. And so the easiest way right now, again, we could do the product rule and actually solve it, but I'm just going to distribute the y on here, and I'm going to get this plus a y. So this is a coefficient times y is equal to x. And then I could take the derivative the way it is right now. So again, when we're taking the implicit differentiation, if we're doing it with respect to x, that means that anytime we have a y, it's going to take the derivative. We're going to have to use the chain rule. So we're going to do the derivative of the outside. So that's the 2. So that's 2. And then we're going to, that's going to be a 1. You don't need to write that 1. And then we take the derivative of the, and then we leave the inside alone. And then we take and chain on the derivative of the inside, which is the derivative of y is going to be the way y changes with respect to x. And so that's the derivative of the first term, and then the second term is going to be a plus. I take the derivative here. A is just a constant, so it's just going to stay there. And then the y is going to be dy dx. And since this is an x and we're taking the derivative with respect to x, it's the same as dx over dx. And so that's going to give us a 1 there. Okay, so now we have the derivative here, but we need to actually get the dy dx by itself. So we're going to factor that out, and we get the dy dx, and we're left with 2y plus a equals to 1. So when you work this out, you're going to get dy dx is equal to 1 over 2y plus a. And so this here is your derivative. And so now I need to use that information. And so I could use the information because we want it at 0, 0, so at the origin. So what I do is I take the dy, put that in pink, and we're going to do the dy dx, and we know we have 1 over 2, and then the y is 0, so we're going to replace that with 0, and then plus a. And so we have dy dx is equal to, that cancels out, 1 over a. So that is actually your derivative or your slope. So we're going to take, now we're going to take the y equals mx plus b. And so we're going to keep the y, and we're going, the slope is the derivative 1 over a, and then we're going to keep the x, and then plus b. Well, this we fill in, so we also know what the x and y is because I still need to know what the b is. So I take this point right there and I put 0 in for y, 1 over a, and 0 in for x plus b. And so that cancels out and you get 0 is equal to b. So the equation of the line that you have here is going to be y, 1 over a x plus 0. You don't need to put the plus 0 on there. But, you could just put 1 over ax, but I'm just writing it. So find the equation of the tangent line to follow up to the following curve at the indicated point. So this is the equation of the tangent line at this point. So that's what it would look like at 0, 0. Okay, let's do one more. So it's the same thing. Here is a different equation on here. If you notice, the x and the y are being multiplied and the y is being squared. So we're going to have to do the product rule, and then we want it at the point 1, negative 1. So how are we going to do this? So we're going to start off again, taking the derivative. And so what we do here is the product rule says that I am going to take the derivative of the x, and then I'm just going to the derivative of x, because we're doing it with respect to dy dx, is going to be 1. And then we leave what we're being multiplied by. And then we add, we leave the x alone. And then we're going to take the derivative of the y squared. The y squared is going to be what we did in the earlier problem up here, where we take the derivative of the outside. So we're going to say 2. And then we're going to say 2. And then we leave the inside alone. That's going to be a 1. And then we take the derivative of the inside, which is going to be dy dx. And then we are going to have that equal to 0. So that is the derivative that we have there. Okay, so then what do we do next? So we have to get the dy dx by itself. So we're going to have, I'm going to combine this and say that this is 2xy dy dx. And I am going to take this one here and move it over to that side. So it's going to be negative y squared. So that's what we have there. And then now I want to get the dy dx by itself. So we're going to have negative y squared over 2xy. And we have a squared up there and a y down there, so we're going to reduce it, and we're going to have dy dx equals to negative y over 2x. So that's reduced on there. Okay, so that's the derivative on there, but I want to know what the slope is at 1, negative 1. This is a slope at every point, but I want the specific point 1, negative 1. So we want to know what it is at 1, negative 1. So then we take our derivative part, and I'm going to put that in here, and we're going to find what that is. So we have dy dx is going to be, that's a negative 1, so that's going to be a positive 1, and then 2 times 1. So I'm just going to write, so that's where we're going to get 1 half. So the derivative at 1, negative 1 is going to be 1 half. This here is my m. Okay, just so we know here, this is my m right there. All right, so now when we have the 1 over x, we have our slope. We want to go back and do our equation. I am going to do that in this color. So we're going to have our equation, y equals mx plus b. And so the y we know is going to be negative 1. The slope is going to be 1 half. The x is going to be 1. And we only need to find what the b is. So when we have this, we're going to subtract this here over here. So it's 1 minus 1 half is equal to b. So we end up having that to be negative 3 halves is equal to your b. And so the equation that we end up getting here is going to be y equals 1 half x minus 3 halves. And that's the equation of the tangent line at that point of this curve. So if you were to graph this curve right here, if you were to be able to put it, you'd have to solve for y. If you would be able to put in your calculator at this point right here, you would find a tangent line with this equation. So it would have the slope, which is the slope that we found right here. That's that slope. And then the y-intercept is found using the point and the slope on there. And that's how you do these problems. Very good.